Now for me, what I would have to do here is if I were at the stage of the game that you're in, grading as many papers as I've graded, okay, because I've graded a lot of papers that have had quadratic formula on them, and people just mess little things up. And probably if you miss this one, it may be what happened to you too. I saw two things on papers here. Well, three things. I saw people just mess small things up. And then I saw people do some other things that we need to kind of address. Don't I need to plug in A, B, and C here, right? So I want to be real careful about that. I'm going to write them down because it's so easy to look back and think, I don't need to write them down. I can just look back and get them. But there's a couple of things that happen when you do that. Sometimes you just mix the numbers up, and sometimes you forget the negative. That's a really common error. So if you did that, that's what about half people do when they're first learning this, so it's not unusual. What is my A here if I label it? 1. It is 1. It's not, I don't put the X's with it, do I? That was another thing. 2 to 3 of you put X's in when you plugged the numbers in, and I think that got you confused. What's the B? Negative 3. We have to remember that negative. If you don't put that negative in there, you're going to get really messed up. You probably end up trying to take the square root of a negative number. So if you ended up taking the square root of a negative number, you probably put 3 for your B instead of negative 3. Okay? What is C? Negative 1. Okay? So now I got to get them in the right spot, but if I've written them down, there's a greater chance that I'm not going to forget a negative, that I'm not going to put them in the wrong spot because I've labeled them clearly. So let's see. A's go here, and it's negative, and it goes here, and it's negative. B's are out front, here, and here. And then we've only got one C, and it's right here.
A wasn't negative.
Oh, you're right. I got on a. I'm trying to talk, and it's like talking and chewing gum at the same time. Some of us can do it, some of us can't. I can't do two things together at the same time today. I've had issues with that all day long. Thanks for catching that. So A was positive 1, and C was negative 1. These two, I could switch them, but they're going to be the same thing, right? One's going to be 1, one's going to be negative 1, because it's 4AC. I put my C where I put my A, but we're multiplying there. That's okay, right? I could go back and cross it out, but it would take a lot of time the way this app works. Okay, so let's reduce this now. Negative, negative 3. Let's do the top first. Well, let's do the bottom first. It's easy. What's 2 times 1? 2. Okay, that was easy. Maybe sometimes doing the easy part first and get it out of the way can get a little build your confidence as you do a problem, because sometimes it's just how freaked out we are about something that affects how we go through it. I got a negative, negative 3, so that turns out being a 3, right? Now, under the radical, I have negative 3 squared. Negative 3 times negative 3 is a positive 9, right? And then let's say that I want to look at that as a subtraction sign. So I'm going to do that in my brain right now. And I'm going to take my finger, even though I can't show it to you on the video, and I'm going to cover up the subtraction sign. And so what I would have is 4, it should be 4 times 1 times negative 1. Oops, I touched it. 4 times 1 times negative 1. So 4 times 1 is 4, times negative 1 is negative 4, okay? Some of you just had a little wobble there with a sign, and you ended up with like 5 under there instead of 13. Isn't that going to be 13? Okay, the reason it's 13, because 2 negatives make a positive. A minus a negative would be 9 plus 4, which I could have just written that as 13, right? Over 2. All right, now number 2, I've got x squared is 64. You could have, in your head, gone, what do I square to get 64? And it's 8, right? Algebraically, what we do is we say, I've got x and it's squared. I want to get x by itself. I want to know what x is, not what x squared is. So it's squared. I want it by itself, so I say, what's the opposite of squaring? And it is square rooting. But when I square root, don't I have a positive answer and a negative answer? I told y'all that at the beginning of class after you got your quizzes, but some of you must not have heard it. You may have been focused already on the quiz. So the square root of something squared is like taking and doing something to it and then turning around and undoing it. That's what it means to be opposite. So I get x equal plus or minus 8, and you would be done then, okay? Back to math. Do you see here that I have a square? That x is caught up inside of a square, isn't it? if I've got that x and it's in parentheses and the whole thing is squared, I can't get down to that x unless I get rid of the square on it. How do I get rid of a square? What is the opposite of squaring? You're always asking, what's the opposite of squaring in this case? Square rooting. Good. So we're going to square root both sides. When I square root over here, I probably should go ahead and write that plus or minus, because isn't it going to be easy to forget it? And some of you remembered you needed to do it, but you did it on the wrong part. Look and see if you did that. The square root of x minus 5 squared is like taking it, squaring it, and then unsquaring it. I get the same thing back. So I get x minus 5 on this side. The square root of 9 is 3, but it has a plus or minus on the front of it. Some of you waited to put your plus or minus on until you moved the 5 to the other side. Look to see if you did that, okay? Because sometimes it's just knowing what you did and how you need to fix that little bitty thing is all it takes. It's like you're really 95% there. This one little thing's getting in your way. That's what I found when I was in high school learning this stuff, is that it was always one little thing. It wasn't the whole shebang. It's not like I didn't get anything. It was just that there was one thing keeping me from doing the problems correctly. So that's what you're probably going to find as you look at your papers today. All right, now I want to solve for x, and I got a weird looking thing going on here. So let me do this. Let me split it up into two different equations. And I'm putting this little lines in here today, and I didn't do it before because I'm thinking of ways to try to help you grab onto some stuff to remember something. Don't I have the equation x minus 5 is 3, but I also have the equation x minus 5 is negative 3, right? Right. So I got two little things to solve for x. This was like 12.2, so we did this last Tuesday. All right, so if we add 5 to both sides here, x is equal to 8, right? A lot of you had plus or minus 8 because you moved the 5 over and then you just put a plus or minus on it. But do you see that I have to move the 5 over to the other side? And when I do, when I've written it the second way out, it ends up negative 3 plus 5. That's not going to be negative 8, is it? It's going to be 2, right? So my answers were 2 and 8. So you square root, right? That's the big idea. We square root, and then we put a plus or minus on that number because 3 times 3 is 9, but also negative 3 times negative 3 is 9. So there's two different numbers that work there. And then we split it up into two equations. Here's the first one. Here's the second one. I want you to remember that a lot of your problems, if you look back at your paper, do you remember that they switched out between that and this? Remember that? If you go back and look at them, some of them say equal 0, some of them say equal y. It's the same thing. It's just that we have set y. When we have a 0 there, it's like somebody went ahead and set it equal to 0 for you so you could solve it easier. Remember how if it wasn't a 0, we had to move stuff around? And so when they've got the 0 there, they've just put it in place of y. I think that was one thing that confused some of you. Okay, so now step 1 was to find our x. If you look at it, these are kind of like what you're going to see as steps now on your new quiz. Step 1, find the x-intercepts. I had that stuff on the board, and so I told you on the board and on the paper we're going to factor to find our x-intercepts. Okay, so here's the equation, and we're thinking, I'm going to put just because so many people had problems with this, I think this was the thing that shocked me the most when I graded your papers. We just got through with factoring, and I think you got so freaked out about everything that you forgot that you already knew how to do this. And a lot of people tried lots of weird things here. Isn't this, I'm trying to multiply to get 4, and I'm trying to add to get negative 5? If you think about 4, the only way to get it is 4 and 1 and 2 and 2. But if I have a negative 5, I know that 4 and 1 will add up to 5, right? If I need a negative 5, negative 4 and negative 1 would work, right? What's negative 4 times negative 1? 4. That's what I needed. So I wanted to factor this as x minus 4 and x minus 1 is 0. I want to point out something because I've seen some papers lately with some factoring on it. I do not put x squared minus 4 and something else in the other parentheses. I split that x squared up into an x and an x. If you're putting an x squared in one of those when you factor, be careful. That might be where you're messing up, okay? Now, that's just factored. I haven't solved it. To solve it, I set the factors equal to 0. I say x minus 4 is 0 and x minus 1 is 0. And then I've got two little equations to solve again, don't I? I add 4 to each side. Oh, just here, not over there. I don't know why I was skipping over there. X equal 4 is 1 x-intercept. And over here, I'd add 1 to both sides. And I'd get x equal 1. Okay, so my y-intercept is the constant in the equation. The constant is just the numeral. It's the one that doesn't have an x with it. So what is the number there that does not have the x with it? 4. If I write it this way, it's the number on the end, okay? So it's 4. My y-intercept is 4. If I were putting that on my graph, that is where it's the y-intercept. You go to the y-axis, 1, 2, 3, 4, you draw a dot on 4, okay? Now we need to find the vertex. And we have to look at the equation again. It's x squared minus 5x plus 4. We had labeled, or we could label that, ax squared plus bx plus c. And I wrote the little vertex equation for you. It's x equal negative b over 2a. It's actually a little bitty piece of the quadratic formula. It's kind of the denominator and the very first thing there. Hopefully by the end of the year we'll have some time where we can actually look at why that works out that way. I want to, but it's just kind of, when we only meet 3 days a week, it's like, hurry, 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 we got to get this stuff in before you have to leave because you got to go home and do some problems on it. All right, so maybe I do this, because a lot of you, again, that negative got a lot of you guys. What is my A here? 1. What is my B? Ooh, careful. Negative 5. Don't forget, big thing. Don't forget, those subtraction signs are really negative. So you have to take those signs as being the sign of the number. It's negative 5. So a negative 5 is a positive 5 over 2. So your vertex is 5 halves something, but when you go to graph it, isn't it easier to think of it as being 2.5? So how do I find the y value here?
You plug it into the equation.
Yeah. Right here, you got to go back to the original equation. You're going to square it, subtract 5 times it, and add 4. I'm just putting parentheses where I see x's, and you got to put 2.5 in there. And I would not have done this by hand. Remember, you are allowed calculator usage, right? And when you do this, what do you get? I think it's like negative 2.25. Is that what, the ones of you who got it right, isn't that what it was? I'm just trying to do it off memory. If I'm to graph this, you had this, at 1 you had a mark, there's 2, 3, 4, and at 4 you had an x-intercept. So here's 1, 2 and a half. Okay, so here's the x value. I got to go down to negative 2 and a 4, so it's just going to be slightly below 2. So let's say you kind of put it there, and then you go, you can connect these. Your y-intercept was up here at 4, and if you wanted another point, do you remember that the vertex splits the graph in half exactly, and you could fold it over and it would match up. It's a mirror image or symmetrical about that line. So you could say, hey, if there was a point this far over this way, I'll go the same distance over and color in another point, and that's how you could get another easy point.